Hi friends, today we will see the important question of digital electronics, that is design the circuit that can be detect the changes in the signal, both edges, positive edge only, negative edge only. So in this video I will see the both edges of the detection of input signal, and in next video we will see the positive edge only and negative edge only. So what is the meaning of both edges? So whenever the changes happen in the input signal, like 0 to 1 or 1 to 0, it should be detected and the output should be high till one clock cycle. So here we can see the two different cases. One is input is synchronized with clock. It is not come exact the same time of the clock. It should be come little bit uh, delay. So you can observe the output in whole cycle. But if input is not synchronized with clock, in second case you can see that input is not synchronized with clock, positive edge is here, and input is changing here. So the output become the glitch like, means it is not on in whole period. So first we design a circuit and after that we will see the waveform of that circuit and understand how we can design for the both cases. So if you design a circuit for the first cases, this cases, uh, so we can use a D flip flop. So this would be input, this is the clock and this is the Q. So whenever the input is coming and the positive edge clock, it will update the Q. This is the Q signal. So in this positive edge, we can see that in this positive case, clock, we can see that it is updating the input, which is 0, and input is changing after some time of the clock. So in the next clock, it is updating the Q as in high, or 1. So and the next clock, it is also 1, because input is changing after the clock, so it should be 1 till this clock. Yeah, at this clock we can see that input is 0, so output is also updated to 0. So with that, we can see that input is 0 1 1 0. So if we write here 0 1 1 0, and here it is 0 0 1 1. So uh, clearly we see that our output is on when input and Q is different, means uh, input is 1 and Q is 0, and here also output is 1 when input is 0 and Q is 1, and if it is same 1 1 1 1 case, it is 0, and when 0 0 case it is 0. So we can say that it is a functionality of XOR gate. XOR gate is um, XOR gate is like that, A B and this is Y. Then A B and Y, uh, when 0 0, it should be 0, 0 1 it should be 1, it is 1 0, it is 1, and this is 1 1, this is 0. So whenever the input is differ, then output is 1, and whenever the input is same, A and B, so output is also 0. Same functionality is here also. See, when 1 0 is, it is 0, it is 1, and when 0 1 it is 1, otherwise it is 0. So we can use XOR gate. So we connect these two with XOR gate. uh, Out. Whenever the signal is changing, and the signal detected whenever 0 is here and 1 is here, output will be 1. 0 and 1, then output become 1. And whenever input is 1 and previous output is 0, output will become 1. So we can detect both edges, means when it goes from uh, 0 to 1, or 1 to 0, we can detect the signal changing. Uh, but in second case, we can see that input is not synchronized with clock, means it changes any time in the clock period. This is the positive edge, and the next positive edge this one, but input is changing before the second positive edge. So q will update in the in this clock only, in this clock only. So input is changing here, and q is updating this point. So 0 0, it is 0, here it is 1, 0 1, it is 0, here it is 0. It is different, so it become 1, but after this clock, it is also 1. So uh, it 1 1, so it becomes 0. And like that, here also it is 1, it is 1, so it is 0, but input is changing at the before this clock, so it is 0, and it is 1. So till this interval, only it is 1, uh, again it is 0. We can see that it is looking like a glitch. Uh, for that, we have to add one more D flip-flop that will synchronize the input and output with the clock. Uh, so we design for the second case. D1 Q1, this one is the clock, D2 Q2, and both are synchronized with the same clock, and this Q is going to D2, and this Q is considered as the output, but this D is input. So we make the same circuit whatever was the previous one, uh, but we added uh, one more D flip flop here. Uh, so in this case, when input is 0, when input is 0, and clock came, it become 1. And at that time, here it is 0, and the same clock it is 0, so it transmit to here. So for the whole cycle, uh, this will be 1 and this will be the 0. So it will synchronize with the clock, and this is the Q1, and we can make another circuit another waveform for the Q2. Q2. So Q2 will be like that at this point. At this point, uh, our Q is 1. So Q1 is 1. So Q2 will be update, and it become like that. So here you can see that it is 0 and it is 1. So our output will be like that. Uh, so for the whole cycle, it become 1. So in this video we see that how we can make a circuit for the both edge detection, positive edge detection as well as negative edge detection. And also we discussed about if input is not synchronized with the clock, means it is not come according to the clock, so how we can add one more D flip flop and make it synchronized and make our output uh, for whole one cycle high. So thank you. In next video we will discuss about the positive edge only and negative edge only. Thank you.